So happy to be here for the third time as a speaker. So that's me, and welcome to the delivering performance, the successful release of Dying Light the Beast. Karan did a great introduction, so I won't waste time on this. And this is Techland. On the left, you could see our headquarters where we are having a party. It's located in Wrocław, Poland. You could know our games like Dying Light series. On the right, you could see the recent one, Dying Light the Beast. And we are also known for Call of War series. It's all started for us in 1991, so plenty of time. And right now we are 500 people in total. We ship on PC, PlayStation since free, Xbox since 360, handhelds including Nintendo Switch, and we got some episodes with Mac as Linux as well. So the plan for today is to show you the basic setup we had to bring the performance to the finish, the process behind it, some tools that become handy, and also how we get external help, and a bit on crashes and how we process them, and also how it all ends. So the basics. First is the team setup. So in general, we work in Jira. We got the technology department and the technology production there that deals with the engine. And there is also the game counterpart that handles the rest. Tech QA is not about QAing technology work, it's about more complex technical stuff. So we could ask guys to do some render doc dumps, some captures in Razor, pics, they could do some traces. And also the dev QA is part of this as they do tools to analyze all the data, aggregate them. So this is a great source for the other teams to work on the performance. Compliance is about providing the first party requirements and ensuring that everything runs smoothly. QA, as usual, so functional thing, they look into everything from the game perspective, so the story, systems, combat, and this also includes the external QA because we use it a lot. The connection between external labs and technology production means that we just deliver builds outside and gather feedback. The feedback is processed by Tech QA, so they check retrospects and provide some additional data for our developers. Okay, so we set up a routine to keep our eye on the performance. This is something that started even before the Beast. Diagram 2 and even 1 was also something that we did that way. So weekly, there was a performance team, the performance core team. I was happy to be part of this. And we had the meeting. It's not super long, up to 45 minutes. TechQA prepared some aggregated data for us, provide some hotspots like some JIRAs that was nasty, so we thought what to do about it. Bi-weekly, we posted on Confluence some summary of the performance, so you could see how the platforms perform, some settings and other just aggregated data to keep our eye on this. And one time per month, the performance newsletter was sent with even more detail, but still not as long, let's say, amount of data to process, to read. And it was all about building awareness and securing time to bring the performance as one of the key aspects of our work. So this is the general process. I try to do my best. I know it looks messy for the first sight, but let's go through it. So on the top left, the whole column is about the sources. So first, we put all the nasty systems into one level. So something that we wanted to keep our eye on. This was called the benchmark level. And aside from that, we tried to reproduce the same scenarios like the players will hit during the play. So we did a bit of scenarios. It was also part of some levels, and guys from the QA was playing those level, and they had enabled the telemetry data, or we were recording this with some longer traces using Razor CPU Live that become very, very handy for us. Aside from the levels, there was some automation. We got our monkey bot. This is a system that is able to spawn on the map, look around, gather some data, everything with the same system as the QA guys. So the telemetry was enabled and the monkey gathers the data in the database. And later on we were able to look into this through the front end that was done by the QA guys. MonkeyBot provided also some measurements of memory. And also we did some game-specific tests like spawning test of prefabs, some population of AI tests, and everything was running on a remote machines. So you could ask for some data, and once everything was done, we were able to look on the front end on the website, and it was there. So the tools that we used to gather and emit the data was the, let's say, common approach with event markers that you could look into Razor, Pix. You work with that every day, so you know that stuff. We got also our own internal profiler that I will show you later. There was some extra logging around DirectX 12 memory because it's pretty nasty right now. So we were looking into this, especially in ray tracing context. And the long performance captures, as I mentioned, was done mainly by Razor CPU Live. And all of that was a source data to feed our methods or our summaries. We were also looking into CPU and GPU spikes. The tools provided by DevQA was able to point them, so we know that some system was not performing well, and yeah, it just needs to take care. So in general, we were looking not only on performance as a constant value, but also on the spikes. And memory, of course, a lot of budgets and things around. Spikes was also part of that. I will show you a bit around this. Once we gathered all the data, TechQA aggregates this, talks to other teams, mostly the core performance team. Then they create a bunch of JIRAs. We did some meetings. We sent some performance newsletters and just built, as I mentioned, the awareness. And all of that was sent to the dev teams. And the dev teams always have access to the source data. So once you have some issue to optimize something, then you could see what was the data behind. You got all the traces stored on the drive, all captures, and everything that is needed to do it quickly. Okay, this is the one of the models of MonkeyBot. This is the view on CPU budgets. On the top, you could see the budgets. They are pretty specific to our engine, but the frame is just the total frame time. The rows are the scenarios, and you just see a matrix how everything works. So different scenarios, different results. It's all about that. Of course, green means good, red is not. And one thing that is worth mentioning here is the percentage under the counter value. This is a super basic histogram because this gives you information about how much samples hit the budget. So if the 19th percentile is green, but for example, the parkour and frame, so we see that only 58% of the samples hit the budget perfectly, the rest not. But in general, the 90 percentile looks good, so there's not much to worry about. Another good thing about this screen was the spikes section on the right. Once you hover something that alarms the monkey telemetry screen, then you immediately see the call stack, what was causing the spike. And aside from this, we get also the GPU budgets, some basic stuff like gbuffer, shadow maps, lightning, general stuff. It's more or less the same as you have, I think. And yeah. So another part of the telemetry screen, the website, was the ability to see all the results in one place. So once you click one of the budgets, you see the budget value, and then you could see the history, how it behaves across different scenarios and in time. We support co-op, four-player co-op. This is a peer-to-peer, so it was very handy to switch the play mode from single player to co-op, and then you saw all the host machine and peers readings all in one place. It was very handy to narrow down some uneven distribution because of the peer-to-peer nature. The load. Okay, so let's go to the tools. This is our internal profiler. This is looks like everything that you're used to. Those are just markers. There is an ability to switch between the mode of output, so internal, peaks, Razor, whatever. And one thing is worth noting here is the section on the right, because I did a small improvement here to give a threshold for this. So if you click on one of the events, the markers, and you set a threshold for this. So for example, you want to catch some spikes. So you click on the main frame, set to 16, and if the marker exceeds the time, once the scope was closed and the measurement was done, it was immediately fired a breakpoint. So once the debugger was attached, you could analyze and inspect on all the data that was there, take a look on some collections, number of elements in some vectors, or do whatever inspection you want, and you got the perfect exact frame to do the analysis. It was very handy. Another good thing was that once you click on something, that it was anchored on the top. So it was very easy to read all the profiles because it was not moving around as always during the runtime. And once you paused everything, you could scroll down and just go into the details as usual. Okay, this is so-called green matters, at least should be. You could switch some modes to see some GPU values, CPU values, render items count, which is the basic unit of rendering and the source of the workload. Aside from that, we always output a bunch of information using the label because we render our passes and not render, record our passes. So also the Razor CPU Live traces contain this kind of info. So you get some insight what was happening in the game and what was the state of the general counters. All of those counters are available in the telemetry, so later on you could see also this in the monkey. This is the front end of the monkey bot. I see I got a new body, that's cool. So on the left you got the main modules, some additional, not only based on counters measurements, like we keep track of the file system, what grows, what was added, what was removed, and just to keep also the size of the build under control. So let's have a closer look. The first on the left is the memory dump. So just providing us information how we keep up with our budgets regarding the memory. The mesh dump was something specific to our games. We divide, for example, into categories like characters, static geometry, LODs. So we know what was changed and what was, let's say, the direction of the change, also to keep the memory budgets low. And the telemetry grid is, as I mentioned, the thing that was able to spawn across the whole map, look around, gather some data. For example, I use it extensively for the texture streaming, just to get an insight what's the pressure on the texture streaming. So it's good to keep, let's say, pretty even, and if some place were spiky, then that means that it was lacking some occlusion or something was leaking occlusion information, and it was just rendered unnecessary, and then those objects were requesting for some texture data. Location list is like a reverse telemetry grid, so you could click on some scenario and see how all of the counters behave and what was the values. Static prefabs is about our let's say our prefabs are done in a way that not everything is able to be divided across different frames when we spawn them. So we keep track on all those prefabs and try to change their structure in a way so at the end they will be able to spawn across multiple frames. And that was about that. I will show it later also. Preserved entities was about different types of prefab. Let's say dynamic prefabs is also about prefabs also, but differently. I won't go into super details. This is specific to our games. Population dump was about AIs. I will show you this later as well. And we got also some pretty nice summary about the general state of the build that aggregates some smoke tests, some performance, so we know if we could merge it or not. The CPU performance view is exactly this. This is the main, let's say, aggregation of the counters. Yep. So once you get into telemetry grid data, on the left you set up which platform you are interested in. You pick a map, you pick the stream, so the, let's say, technology stream or content stream or whatever, release stream, for example. The configuration of the executables. Sorry, some Mac window pops me. Okay, the graphics profile, because we use profiles for the graphics, like low, medium, ultra, so you could pick it and see what was the measurement. The player is about single and co-op, and you could additionally filter out using the regex and whatever. So once you pick it and filter, you see the first thing on the right. On the top, you could pick the counter that you are interested in. This is the frame time, as I see. So you got the readings in history of different builds. And those circles are 2 points that will be source of comparison. So one is the reference build and the other is the inspected. So for example, the previous patch was like that and the next patch looks like that. And you pick just those two circles just to see the differences clearly. Additionally, you could ask AI to filter out and take a look into the change list and try to get some answers for you. It was very handy for TechQ guys also to why the memory used by meshes rises. And it searches and okay, level R did some upgrades because of something. And yeah, it's most likely that. And it was surprisingly working good. We were pretty happy about this. It was not super widely used because it was quite experimental, but yeah, we are surprised that it's working pretty nice. Okay, and this is the main view of the telemetry. So you got the whole grid on the left and on the right. This is the reference and inspected builds. In the middle, you get the difference. So it's pretty easy to narrow down where something is going up or down. This is in the middle, you get also the counter set you could pick. More of this was also visible on the green counters. And yeah, once you click a cell, then you could see where it was placed. And so the view on the left shows you the cell on the map. You got the coordinates, you could copy it over and paste and spawn instantly in the game just to check what's there. It's very easy also to put into the Jira that, so for example, for level art, yeah. Guys, here we got a lot of render items. Please take a look here. Exactly, that was the measurement. You could also pick some counters to get some histogram. This is visible on the top. So I selected CPU render and GPU. And if you move the ranges, the grid reacts in a way that once one counter and another counter met the range, then it was highlighted. It was also very good to narrow down and focus on things that are super important from the performance perspective. This is the memory dump. It worked in a way that we started the game. It was, let's say, the 0 point, like here. And then it moves in a series of locations just to warm up all the systems so we could observe how the memory requirements and also how the system behaves over the time. Again, you got the reference and inspected build, so you could take a look if some change introduced some regression on some budgets. And on the bottom, you see exactly what budget was affected in a good or a bad way. So green, red, easy stuff. If you click on one of the budgets, I clicked on the mesh, then you could see the history of the readings and also all the call stack that are assigned to that budget. So you could, for example, now see that some place is taking more space in memory, and it's pretty easy to put everything in Jira and just directly point the developer to improve something. This is the population dump. So this keeps tracks on our zombie population. Again, some places that were too heavy. I mean, the level design did too much in one place, and it just takes too much on the frame. Then we just saw it here. It's also about spawning and some AI logic. And this is the view of the static spawning. So yeah, not everything went perfect at that reading. Some items were red. It was just about keeping track on those prefabs that might cause some spikes during spawning process. So if you play the game and encounter something. The quick test looked like that. So we knew if the technology that we want to merge to the content is good or not. It's all about bringing, let's say, good experience for our content base. Now the data brain, we use it. We integrate a lot of telemetry data inside. On the left, you could see an overview what we got right now. One of the coolest things there is that main dashboard that's got everything in one place. You got the heat map. For example, on the right, there's the crash heat map. So we know where the game is crashing, and we could point QA to look around. On the bottom, you could see the unplayable FPS chart that looks pretty nice. For the console, it's below 0.1. It's from the release, let's say. So yeah, very handy tool. And this is another example of the charts that you could get from DataBrain and the FPS chart. And also, it was looking pretty nice. It was also from some release. Yeah. And example of the newsletter. This is the Beast performance report. On the top, we got very easy to read, let's say FPS. So it's easy to understand if the game is running smooth or not. Some comparison to the history data. Later on, there was some more detailed information, and it ended with some conclusions with a few JIRAs that the developer teams should focus on, and also some production stuff like some summaries of done work marked by some labels. My friend Andrzej was marking everything with CPU, GPU, memory, so it was pretty easy to filter out how many issues of different type we have. Okay. And a bit on the engine features that we got. So in general, we got different game modes, 30 for the quality, 60 plus because of the VRR possible presence on the consoles. And this is for the console. So we got two modes on the consoles. In Dying Light 2 was 4. We reduced it to just to ease out the QA work. PC works the same way, but we got many more presets from low to ultra. And also we use auto detection to get insight into memory and GPU, some device ID magic as well, just to propose something cool on the start. So the player is not seeing stuttering game, but instead it's smooth for him. The video preset files were done with a great help of TechQA guys. They were trying to find the best mix of quality and performance. And at the end, we ended up very happy with this collaboration. We wanted to be Steam Deck verified on day one, so we prepared a dedicated performance preset. It started as a low from PC, and with some additional tricks here and there, it was tweaked to get pretty nice performance on this device. DRS was helping mainly with the uneven distribution of load incoming from the level art. Dynamic resolution scaling, easy thing, but very handy. So if you don't have it in the engine, I encourage you to try it. I mentioned the memory allocator dumps. It was very important for ray tracing because of the whole BLAS and TLS memory requirements. So we're just putting some data into the logs, the dedicated file, and later on some Python scripts were just outputting some nice charts according to different buckets of allocations. So this way we know if this is a texture streaming issue or some ray tracing issue, all about not to overcome it, the VRAM memory. DirectX 12 PSO Pingy, you all most likely love it. We got our scripts and for the render loop, and we got full control over materials, so we know what is drawn where. So we are able to prepare all the PSOs needed, but it was too much. So we went with very basic idea just to log everything that QA is playing, and then all those PSOs was aggregated into one list, and we use it as a preload. So once you start the game, you see the corner that PSOs are being preloaded, and this way there is very unlikely to hit a PSO creation during runtime. And if you encounter one or two, it doesn't affect the performance. The problem is when you got tens of this, and this introduces super nasty spikes. So very easy way of dealing with this that worked. We use upscaling and FrameGen. Ray tracing enables frame generation by default. This was a bit controversial inside, but at the end, everyone was happy about it. And the funny thing around this was that the ultra mode performs sometimes better with the high quality settings because of this, despite the high load incoming from the ray tracing. So you have ray tracing and the game was faster. It was sometimes funny to see it. Steam Deck was using frame generation as well. We were able to hit 90 on the screens. The game was running with HDR as well, and I encourage you to play it. It's very nice experience. And of course, a lot of that's the usual programming stuff. So caches, pools, and all of that just to avoid allocations and some collision on some internal mutexes. A few words about external help. We appreciate great support from our partners, so Intel, AMD, and NVIDIA Labs. They helped us a lot when it comes to verifying the min specs, recommended specs, and other compatibility tests. So we were checking different series of GPUs, CPUs, Intel greatly helped with laptops. The Beast was the first title that we officially support the laptops. We did some driver optimizations together, so we were ready on day one with some updated versions of those. And to ensure that everything is run smoothly, we had better access to do QA on our end as well. And we used also external labs to fine-tune the upscaling and frame generation, like the latency reduction due to some complexity of our engine is not very, let's say, easy to implement properly, and we were ensuring that we did it well. GTDR is a Tencent thing that had a lot of impact on our tests. They helped us a lot. We get a lot of data from them. They were doing a lot of, let's say, over hours for us just to help us deliver the performance on time. I really appreciate this support. It was great to work together. And we also had some reports regarding performance from external QA during the functional QA passes, like some missing texture, some blinking, some stuttering here and there, and some glitches in general. Yeah, a few words about crashes as well. So we are using Sentry right now. We aggregate all the data from PC and consoles in one place, and this is very, very handy for us because this is all in one place to analyze and get some stats. TechQA is just looking inside and puts Jira on the top offenders. We got still access to recap and all that, let's say, first-party regular stuff. We could ask for a dump if needed, and everything works still. But and Data Brain, as I mentioned, is for the performance, but there is also a crash, like you see the heat map. It's very nice and handy tool as well. So after the release, guys from publishing and also QA were monitoring all channels that players could output some complaints or point to some issues with the performance. We were trying to streamline all patches and fixes around this just to deliver the fixes as quick as possible. On PC, it's pretty easy, a bit longer with the console, but still we are trying to do our best to react quickly. And to keep track on all of this, we are sending emails regarding the stability. This is the look on the Sentry. So if you don't use it, this is how it looks. You get access to dumps, to logs. You see the platform, some stats about the events, crashes, everything is here. Very handy tool. And you don't have to switch to different free websites. It's just one and has everything. This is the crash summary mail I mentioned. So top offenders, everything sorted, some Jira links, status, and also at the bottom you could see that the crash ratio on PlayStation 5 was pretty low, below 0.4, let's say, so pretty nice. And this is the performance report on the end from the day of the release. You could see that we were super happy about the release. Everything went pretty well. There was a lot of pricing across the internet. You could check those YouTube videos and take a look in the comments. In general, the unplayable FPS was very, very low, and everyone was happy that we did pretty well with this. I've put some comments from this. I've copied them from top of the first YouTube video just to give some positive energy to those of you guys who are still keeping up with your own engines. It's worth it. As you see, people were very happy. And a few surprises. So recording software caused a lot of issues for us. So OBS or everything that was injecting or messing with swap chains, it is something that is pretty problematic. We saw this on Sentry multiple times. Some hacky modding software that injects also something exchange, some DLLs tries to mess with addressing space. This is also something that pops on Sentry and is visible on PC. It's pretty easy to narrow down the pirated version because you got old executables and new data, and it's incompatible, sorry, and it just crashes. So we are right now marking the pirated versions to ease out the QA process because it's already filtered out. We know that it's pirated more likely because of some CRCs, and we don't care, let's say, because this is the consequence of incompatibility. Driver issues. So yeah, you all know about this new driver, new series of GPU hangs, for example. Windows updates, it was also something. There was a period of time that each and every update was causing some new issues with memory allocation, some extensive time needed for allocations, a lot of stuff. Right now, everything is fine, but it was let's say two updates that was very messy for us. And of course, usual PC stuff, overheating, instabilities, so a lot of GPU hangs coming from that. We on the release in the beast, this was the first title, we put some markers just to see when the GPU hanged. So we got some stats and we know if something is repeating, and we could put QA there, or something is pretty random and we should just no, maybe not care, but this is a result of some hardware instability and we are unable to do anything about it. Okay, so thank you for being here, and you could reach me out on Slack if you got some questions. As always, you could catch me on LinkedIn as well, and thank you for your time.